All right, here's a couple of radical questions, simplifying radical expressions. Both of them have a cube root, which typically is just a touch more. You have to do a little bit more thinking. So initially, we have a rule that says if you have the square root of a times the square root of b, that's the same thing as square root of ab. And I probably do that here. In other words, I can multiply the radicands, the stuff underneath the radical. So I can rewrite this as 2 times x plus 4 times 4 times x plus 4 to the fourth. Then I see that I can multiply the 2 and the 4. They're similar factors. So cube root of 2 times, now 4 I'm just going to write as 2 times 2. Okay, and then I can multiply this by this. And since they're the same base, it's like multiplying x times x to the fourth, like that. And so if they're this multiplying the same base, you just add the exponents. So this one would be x plus 4 to the fifth. Okay, now the definition of cube root is I'm needing, or I guess the process definition is I need 3 identical things inside, and I can bring one out. Sharon Hendrickson used to call it prison. So underneath the radical is prison. In order to get out, you can get one guy out, but there has to be 3 combined to get one out. So here's 3, and and since it's a cube root, I can take 1, 2 outside of this cube root. Okay, so these are gone. And then x plus 4 to the fifth, this 5 means I have 5 of these things. So there's more than 3, so I can take 3 of those can become 1 outside, but how many will I be left with inside? Hopefully you said 2. So if you had 5, so 3 of those come outside to make 1 outside, and inside you're still left with 2. Okay, and I'd probably leave the question just like that. Since there's only 2 of these, you can't bring anything more out. All right, here's another question where you need to, again, you're dealing with cube roots, and you're wanting to rationalize the denominator. Rationalize the denominator. Okay, so if it's a square root, like if I have 5 over the root of 2, all you do is multiply the top and bottom by root 2, because on the bottom, then you get the square root of 4, and the square root of 4 is an exact number 2, and there no more denominator on the bottom. The reason why you multiply it by this number here is so that you can get one of those pretty numbers. And I call pretty numbers the ones for square roots anyway. So 1 squared is 1, 2 squared is 4, 3 squared 9, 4 squared 16, etc. Those are the pretty numbers for squares. For cubes, the pretty numbers are different. So 1 cubed is 1, 2 cubed is 8, 3 cubed 27, 4 cubed 64, etc. So here what I'm wanting to do is multiply top and bottom by something so I get one of these pretty numbers over here. And it looks like if I multiply the bottom by a 3, then I'm going to get that 27. But if I multiply the bottom by the cube root of 3, got to multiply the top by cube root of 3. Okay, so I'm multiplying these. So this is going to be equal to, on the top, I'm going to get the cube root of 48. And on the bottom, I'm going to get the cube root of 27, which I know is one of the pretty numbers. So in the bottom, I get a plain 3. Happy day, I'm done, almost. So the 3 is good. I've rationalized the denominator. But then I look at the top, and anytime you have a radical, you probably want to simplify that. So 48, what I'm looking for now is, does one of these pretty numbers divide evenly into 48? And it turns out that it does. So I can write this as the cube root of 8 times the cube root of 6. That'll give me 48 over 3. Dying to divide the 3 into the 6, but I can't because this one's outside a radical, this one's not, or it's inside a radical, so I can't touch them. But the cube root of 8 is 2. So the top thing would be 2 cube root of 6 over 3. Hopefully just describing how I would go about those questions helps you out a little bit.